Okay, this is lab 8, and let's start by opening the same file. Okay, and in this lab we're going to first we're gonna correct this gluing and also the spider. We will put another spider here at the very end of this tip, and we can apply a force here and on the other end. So we will remove some nodes from this big spider here and give those nodes to the end spider. Okay, and second we're gonna give the shell and C bars the dimension thickness and the diameters as well as the materials, and then we're gonna create a clamping material here. So the clamping object, it will be a 2D shell, and its material is going to be polyethylene, which is a little bit different from what Dogzada did in the class. And the thickness will be 0.1 inch. Also, so after that, we are going to build a coordinate system here from the end, which I said before. We're gonna create a spider here. So from the end pointing to this end. So that will give us a nice coordinate system which you can apply two force that are opposite and equal. Okay, so that's pretty much what we are going to do today. And so first, let's start doing the gluing here. Okay, and let me see. Gluing, you can delete the lower half. Okay, and then we modify the first one. Or you can delete both and create a new one. Let's create a new one. Surface to surface gluing. Okay, and if you remember, that's gonna be manual type. And turn off all those. Turn on this part of the jaw and the handle. Okay, so let's start from the source region. Okay, we need a new region, or rather we had 4 regions here. Well, let's just create a new region. Let's say it's a jaw. So let's start from the 3D mesh, and it's gonna be on the top. So from last time we picked the element. Okay, so that's why we have all the arrows pointing up. Um, now we have some new method that we can use future angle element face, which is we're going to pick up the face of this 3D mesh. Okay, so we pick this method, and you can. It's similar to feature angle face in the when you build the spider. Okay, then we can pick the any element face on this big surface. Okay, so now you can see we picked up the surface of this 3D mesh. So we are also going to pick the bottom of this 3D mesh. Yeah, so this way we will not have the top and the bottom two separate gluing. We're gonna put them in one gluing. All right, so that's for the 3D part. That's okay. Then for the target part, okay, we also need to build a new region. We can call this handle. Okay, so and now we can either no method, or you can pick the whole handle like Dogzada did in the class. Okay. Well, personally, I will just pick some of this. So turn off the solid. Then we have 2D mesh only on the screen. Then you pick some element. which is, you know, beyond the overlapping area. So that's the region. And be careful, we should pick the bottom of this 2D mesh, which is the inside face. Okay, so it should be the bottom. Okay, and so we will glue the bottom surface, the inside surface of the handle to the top surface of this 3D mesh. And how to control that's the search distance. So if you gave it, like for instance, if you gave it a 1-inch search distance, then the gluing will start from here to whatever within the 1-inch sphere. So we want to make sure this distance is not too big, and you can measure this and give it a little bit bigger than the gap between this. I have already measured this, and I believe Dr. Zada did a pretty big number in class, which is a 0.3. And I measured this; it's about 0.05 something. So I will use 0.051, which is bigger than this gap. Okay, and then you can click OK. You can try 0.3. I don't think there will be a problem. Alright, so now you can see the arrows, they're pointing up and down, okay, which is reasonable. And also you can change the display by right click here and edit display, okay, then make them smaller, apply. Alright, so it's not that messy. Okay, so we are done in the same. We can go to the fan part. Let's double click here. Okay, now in the fan, first we're gonna modify this spider, the spider here. Okay, so we're gonna free the node on this very bottom edge, and grab all this the node on this edge into a spider, and that spider will provide us a anchor point, or the anchor point for the force we're gonna insert on this part. So first, pretty much we're gonna delete this. Okay, so we are going to delete the spider, which is, if you can find them, this one. Depends on what you have. You can delete this, and we want to see the node on this screw. So we can go to Preference, Model Display, and change the marker type to this one. Okay. And now we're gonna insert a new spider for this piece. So maybe hide the handle first, then insert 1D connection and RBE2. Okay, source will be the node on the screw. So by picking up this screw, this node on the C bar, we will, as we did last time, we will anchor this RBE2 onto this C bar. There's no C bush between them, so it's a rigid connection. Okay, next is the target. Now we need to turn on the handle, and you can, if you didn't move this piece of mesh into the same collector as this one, now it will be very easy to pick up node. And since I have moved them together, so I cannot pick them easily, because if I use some filter, it's gonna pick up the whole thing. Okay, and I have to do this. Maybe F8, then move it a little bit here. Okay, so we're gonna free the nodes on this edge. So here we only pick the node on the rest of the surface. Okay, and it's saying I just pick the source. It's fine. It will not do that. Um, okay, and we can put this into the collector of handle A, which is a bigger handle. Okay, and let's click apply. All right. So now you can see we just freed these nodes on the edge. Okay. All right. The next step is we are going to put a spider to grab those nodes on the edge. So first we need a center node for the spider. For the center node we need the CAD model. Okay. Now we have the CAD model, and we can go to Insert, Node, Create, and you want to grab the center of this circle. Okay, and click OK. There's one node for the spider. All right, so we have one node, and we can click 1D connection. The source will be this node, which is on the well, it's not connecting to the C bar. Okay, the whole purpose is just put a force here in the same, so indirectly you actually put the force on this bottom edge of the handle, which will simulate the you squeeze the handlebar. All right, and that's the center node. Then the target is the edge. So here we're gonna use a method called feature edge nodes. So we'll pick all the nodes on this edge. Now you just pick one edge of the whole edge, okay, like this edge, and you will see all the nodes on this edge is highlighted. Okay, and we want a new collector. Actually, we can put this back in here. Okay, let's put in the same collector of the bigger handle. Okay, that's okay. Click OK. All right, now you can see we have two spider here. The bigger one is to grab the C bar to the handle. Okay. The second one is grab the end edge of this handle, but it's not connected to the C bar. Okay. So the center of this smaller spider is just for the force. Alright, so we're done here, and next we're gonna give the pins the diameters. Okay, and I will only show you one pin and probably one thickness, and then we'll accelerate the video because it's pretty simple, and it's basically the same as what you did in the homework. Okay, and we don't need all the 2D or 3D. Let's start with the pin. Alright, so bear in mind that the bars, if you put them under the same collector, they will have the same property, which is the diameter and the material. So the good thing here is we put two pins under the same collector, and these two pins, they indeed have the same diameter and of course material. And that pin here, this pin is for the on the bigger handle. That pin has different diameter, so we're good. And now let's define the material and diameter for these two pins on the smaller handle. We can right click on the collector. Okay, so we should right click on the collector level, edit, and go to edit again. So you want pick steel. Well, I have done some material here so you can see them in the manual. Basically, you open the material library, then you pick steel. Okay, double click now. just click still and click OK. And the cross section, we can click this icon, and you want to build a new one. And for this this pin, it's gonna be a 1/4 inch in diameter, which is 1/8 here for diameter 1. So we're gonna input 1/8, click OK, then all the way OK. Now you can see the difference. You can see under some 3D shape coming out. Alright, then next is the thickness of the sheets. Turn off the 1D and let's turn on the 2D. Okay, we have two different kind of thickness. The handles, they have the thickness of 3/32. Then the connector has a thickness of 3/16. So let's start at the handle, the smaller handle. Okay, and here you can, since you have already picked the material from the pin, so you can pick them, find them in the drop-down menu. And the thickness for the handle is 3/32. Okay, and basically you're gonna do the same for this part. Okay, or you can just pick P shell 1 because they are the same material properties. Okay, and then the collector is different property. It's actually this is 3/16. Okay, and it's again it's steel. Alright, so we have the material for the handle and the connector. Then see. Okay, next step is we are going to create a small piece for the pliers to clamp on. Okay, then there's some birds outside my house, so let's turn off the nodes display first. It's kind of messy. Alright, now we're gonna create a small piece here, and it's gonna be 2D mesh. So and which connects to the jaws by C bush. So first we need a coincident node here, because you don't want to create right on top. You don't want to create the element on top of these nodes. They are occupied by the jaw. So if you create that way, the piece will be welded on the jaw. So we need 4 nodes first. We need to create node. Okay, and make sure it's on invert, and we can pick the center 2 node and create 2 nodes on top of them. 1, apply. That's 2 node, and I'm adjusting the view this way, and there will be no nodes behind this 2. If you do that this way, you will have a lot of nodes, and that will be probably you'll grab some node in the center, in the middle of this 3D. So 1 node, another node. Alright, now we need to put 2 nodes in the center. So we can turn off the 3D, give us a clear view. Then we can go to insert node and between nodes. Alright, so between that 2, apply, between this 2. Now we can click OK. Okay, now we need to create the 2D mesh. So this is gonna be the 2D manual mesh. So we go to insert element and create. Okay, so here you want to choose 2D and C quad 4 and the auto creation. So auto creation, because we need to assign it a different thickness. And also the the order of picking nodes, you have to be careful. Okay, so we want the normal to be up, to be pointing up. So we should go counterclockwise. So which the up is y positive here. Okay, so you should pick in a counterclockwise manner. So from here to here. Okay, and use shaded mode, and also from the same order. Okay, we can add to existing, put them in one mesh, and let's see where the mesh goes. Okay, yeah, so it's a new mesh, and you don't have to rename, personal preference. And okay, let's see which normal this thing is. 2D element and normal. Pick this. Okay, if you have separate mesh, you should pick 2 and display normal, which is on the y positive direction. Okay, so good, and give the sheet a material and a thickness. So let's open the material. Okay, it's gonna be polyethylene. So let's go for polyethylene. Okay, and the thickness is 0.1 inch. Okay, all right. Now we have assigned the material for the sheet. Also, now we need to connect this piece to the jaw via some C-bush. And here from last week, the C-bush for this connection, for here, okay, on the screw and the connector, it's a ball joint type of connection. It has all the 3 translation disabled, rather big, and the rotation are free. So those 4 C-bush here are gonna be the same as this one. I'm gonna put those C-bush inside this collector. So now I'm gonna rename this to rotation. So only rotation in this C-bush, or you can name it like a ball joint, something like that. Okay, and let's start here. I think you can do a 1D connection. Okay, C-bush, not sure. Yeah, I don't like this. Insert element, create 1D C-bush, and let's put this in C-bush rotation. Okay. Now let's pick the nodes. Again, we're gonna rotate at this perspective, and so you can see there's only 4 nodes. Okay, so let's create one first. This way, there's no structure, no element behind this node. So you can only pick this 2 node. 2, okay. One spider, since they're in the same collector, it will automatically show the text. Just simply click twice. And for this on the top, you want to rotate. Now there's nothing behind those nodes. Just click twice. Now you have 4 C-bush. Okay. You can see from where did they go? Yeah, they're under here, but oh, okay. I think I put them under the same mesh. Then undo, undo, undo. All right. Okay. Insert element, create C bush, and I want to create new. Yes, that's it. Then 1, 2, 2. Okay. All right. 2 and a new one. Then 2, 1, 2. Okay. So that's all right. We have 4 spider here, 4 C bush here, which is 4 here. And if we want to make sure you can, do adjacent check, select all the piece, apply. That's all your C bush. Then select everything, apply. Then that's your jaw. Okay. All right. Now we have uh, the piece done. Next is the coordinate system. So we need another coordinate system here from the end of this handle to that piece, to the end of this handle. So this way we can measure the displacement on this direction, and we can put two forces opposite to each other right on the coordinate system axles. So let me turn off this screw first. So we're gonna start from this point, the center of this. We can even turn off this. Well, leave a small handle. Also the big one. So it's gonna be the origin of the coordinate system gonna be the center of this spider, and let's start. Insert. Okay. Insert. Model preparation. Then it will be a coordinate system. Now you want to make sure it's a Cartesian system, and now you can use z-axis, x-axis, and the orange. Okay. Now the orange will be in the spider. Why is it showing up again? Turn off this. Okay, maybe turn off the big handle. Now turn off this. Okay, so the orange will be here, and I want z to be the same z as the absolute system. Okay, now the x-axis, it's a little bit tricky. You want to open the vector dialog. Click here, and you want to choose 2 points. Okay, so pointing from the center of this spider to the center of this tip. Now, after you pick this point, okay, since this one is not exactly on XY plane, so it has something on the Z coordinate. So we can open the point dialog by clicking this icon. Then you can see the coordinate of this point. We're gonna change the Z to 0. So our X will be the X in the new system will be on XY in the absolute system. Okay. Alright, so you have Z is the same Z as the absolute. X is from the center to this point a little bit off from this point. Okay. Now we have a coordinate system. Okay. So We can check, first let's check the material, and we can right click on the top on this bar, on the name bar. Okay, then you can see a material view. So let's transfer this to a material view. So nylon is the one you did in class. We have changed that to polyethylene. So let's turn off everything first. You can turn on steel. Now you can see steel should be the pliers. Okay, so that looks pretty good. Then the polyethylene should be the small piece. Okay, no material. Let's see. Yes, the polygon has no material, and as well as the C bush, RBE2 C bush. Okay, you don't want to see any C bar here. The C bar goes to the steel part. Okay, the bar. Three C bar collectors in the steel collector. Alright, let's go back to the standard view. So you right click on this bar and the standard view. Okay, the fan part is down here. Okay, and we can go to the same. Okay. Alright, now in the same, we're gonna apply load and constraints. So first, let's apply load, which is 2 force, and they're opposite and equal. Well, it's a little bit off. Okay, so first we want to make this coordinate system as the working coordinate system. So xc now the xc is on the absolute system. So let's expand this coordinate system and right click here. Oh, close this first. Right click here, and you can set this to set to working coordinate system, WCS. So now you can see the X, C, Y, C are on this system. Okay, and let's apply force. Now you can apply X minus on this point of the handle. Okay, then give it a 10-pound force. Apply. So you can see that's why we need the coordinate system. It's aligned on this, aligned with 2 handle. Now the second force is we have to hide something. Hide the bar of the screw. The second force will be applied on the center of this spider. So first it's gonna be on X positive, and then second we're gonna pick the center node. Okay, if you don't want any interference, we can turn off this. We'll make sure it's on the center of the spider. 10 pounds on X positive direction. Okay. Can turn the other things back on. Okay, so now you can see the 2 loads. Okay, then the constraint. We're gonna constrain this piece. Okay, so we're going to use a fixed constraint and grab this 2 node in the center. So you want to see 2 nodes, 2 objects. Then click OK. So we have load, we have the constraint. You can try to do a model setup check. So you will get this warning, don't worry about that. You should have no errors, okay, no errors. And if you have some error, you just read the text, and it will tell you like material, or if you didn't free this spider, if this spider, is two spiders share this the node on this edge, it will also have a error. Okay, so now let's try to all right. Turn off, and let's go to the results. Okay, so since I mean now the all the numbers are based on this coordinate system. Okay, if you want to change back to the absolute, you have to go back to the same and change this. Um, well, I think I have to look how to change it back to the absolute system. Oh, maybe if I click here. Well, for now, anyway, for now we are stuck here at this system, and so you can compare the number to mine, and let's see the results, and you can also, look around what kind of a stress the displacement, and later on we're gonna show you how to. Now you will be asked to hand calculate some of the force and the momentum, the moment. Okay, and to check the model, to check the analytical solution with comparison to the simulation solution. Okay, I think that's it for this week, and pretty much we have done the fan part. Next week probably we will have no lab, and even if we have lab, that will be some change on the material, some change on the load condition. So This might be the last lab, and the next lab will be if there's no lab, and it'll be F and Q. Okay, that's it for today, and no homework for today. So get ready for the final report. Thank you very much.